Yo guys, how's it going? Nice sunny bright day today. It's a big change from me shooting, in the dark with a ton of artificial light, so it's a little nicer. Hopefully makes my face perk up a little bit. I know there's a lot of gamers out there, especially on YouTube, and I've gotten a couple questions about video cards and GPUs and kind of how they work in some of the comments. I don't play a lot of video games anymore, but I had my heyday back in the day with my Voodoo 3 Radeon 9700. If you don't know what those video cards are, I might be substantially older than you are. In this video, I'm gonna spend some time to try to give you guys a basic intuition behind GPUs and video cards, so let's do it. The fundamentals behind GPUs and video cards come back to computer processors. So I've already made 2 processor videos before, and I really think they might be worth watching if you want to get the most out of this video, so please go check them out, and I'll probably still be here when you come back. So the first thing we have to do is split apart the GPU and the video card. They're not the same thing. Let's talk about the GPU first. Alright, if you guys remember from the other videos, I talked about this thing called an instruction set architecture, or ISA. All processors are responsible for implementing a particular instruction set architecture. So all a GPU is a specialized processor that implements an ISA that revolves around images and graphics. The other instruction set architectures I mentioned in my other videos, x86, ARM, those are all very general purpose instruction set architectures, and they're implemented by very general purpose CPUs. GPUs, on the other hand, are extremely specialized, and they implement a very specific instruction set architecture that we'll talk about. So when I introduced processors, I made an analogy to chefs in the kitchen. So going off that analogy, a general purpose processor, commonly known as a CPU, is probably like a chef in the kitchen that can do everything just okay. A GPU is like a pastry chef. The pastry chef dominates all things pastry in the kitchen, from baking to whisking to, egg cracking. While a general purpose processor implements a very general purpose instruction set, a GPU implements an instruction set that is super focused on graphics. These 2 instruction sets are inherently different. So while a general purpose ISA might have an instruction that adds 2 numbers, a GPU might have an instruction that adds 10 numbers at once. They might have instructions to do fancy math algorithms or manipulate a lot of data at once. Anything that revolves around image processing. A general purpose instruction set might never need to implement an instruction like that. The pastry chef needs to do high level pastry things, while the general chef doesn't really have to do any of that stuff. Final takeaway from this is that a GPU implements a very specific ISA that a CPU wouldn't. So we understand GPUs a little bit better now. Let's talk about video cards. There's 2 main ways a computer system handles graphics: integrated graphics and dedicated graphics. So if you're a hardcore gamer, you want to run everything on max res at 60 FPS, you almost certainly definitely have dedicated graphics. If you're just an average Joe and you don't play a lot of video games, you're probably just running integrated graphics. Integrated video just means that your computer can handle graphics and images without a dedicated video card. Oftentimes, the performance of integrated graphics isn't quite as good as a dedicated video card because your computer has to share a lot of the same resources with all the general purpose processing. So one shared resource, for example, is your RAM memory. If you're using integrated graphics, the general processor needs to use a little bit of that memory, and the graphics processing needs to use a little bit of that memory. You can imagine this saves a lot of power, but you're definitely not going to get some high-end video performance out of something like this. So for all the gamers out there who don't care about power, 1000 watt power supplies or whatever, you guys almost certainly have video cards. What a video card is pretty much just an extension on your computer that provides dedicated graphics to the monitor. Once your computer system has a dedicated video card, you'll never have to use integrated graphics anymore, and it'll free up a lot of resources. So you can imagine if your RAM was being shared by general processing and video processing, once you get that video card, all that memory is freed up because the video card itself has its own memory. The GPU we talked about earlier lives on that video card, and the video card is that big, huge thing that you stick into your computer. So what else lives on a video card besides the GPU? a video card has dedicated RAM memory, which is solely used to store graphics and image data. You also have those big heat sinks and fans that are cooling your GPUs just like you have cooling your CPUs. And do you guys remember all the caching and memory levels I talked about in my hierarchy video? All that stuff is relevant to video cards too. Video cards not only have dedicated memory, but they also have various caching layers to optimize performance. So upgrades to your video cards are really similar almost to upgrades to your whole computers. GPU cores run faster, memory gets bumped up, more graphics instructions can be run in a shorter amount of time and they get more efficient. These video cards have gigs and gigs of dedicated memory. They're beasts. So all those things are all inside your video card. Dedicated memory, heat sinks, GPUs, caching, fans. It's like a whole computer almost. Alright guys, that's the end of the video. Hopefully it was nice and sweet, but the major takeaway I would think is that don't use the word GPU and video card interchangeably because they're different. Like I said, these video cards are like computers. They're monsters and there's a lot of stuff going on in them. If you're interested in more of the details behind how they work, really encourage you guys to Google it or do your own reading on how video cards and GPUs work because they're really complicated but also really cool. Alright guys, that's the end of the video. Hopefully gave you guys a little bit of intuition behind those really huge video cards inside your computers right now. And talk to you guys next time, alright? Later.